I will share my screen. Lori, could you please confirm that you see craft window?
Yes, it's on the screen. Yes,
Yeah,
we can see.
yeah, thank you. And you also see my temporary folder.
Yes,
nearby.
it is open.
Okay, good. So we have weather data uploaded. As I said, I have another data set already ready for you to work with. For entire CMDT region. And it is called Enacts version 1, and we will use for this our exercises because this one contains just 10 cells, 5 or 10 cells, and that's not enough. Our region is quite big. Nevertheless, I might select this smaller region. Okay. Next data set we discussed was the soil profiles. Let me talk about that a little more. So in DSSAT for 7, there is a special folder which is called soil, and it contains all soil profiles we are using in DSSAT. All of them has the SOL extension. Some of them starts 2 letters, and it should be that way. And for our case, we are using ml.sol, this file. Let me open this one. This is the file. I'm just showing the dots because this is how it's separated. It's the position sensitive. Let me turn that one off. That's how it looks like one soil profile. So each soil profile, we have the associated soil profile ID, this one. It starts 2 letters, ML, and the file is called itself ML. See, ML, everywhere is ML, is the file name, and then comes the number. But the code itself is entirely this word, ML, etc. It contains also latitude, longitude to match our locations. So this information, it currently contains thousands of soil profiles for entire Mali. It is based on ISRIC global soil data combined with HC27 harvest choice data. So they are providing mostly this kind of data. And as I mentioned, there is a special tool. I showed the reference to that manuscript, that free available, and you can use by latitude, longitude, it can generate this kind of soil profiles. That might be helpful. Or you might find some other sources. But the idea is that we should have this kind of soil profiles for your location per grid cell. If you are able to prepare, I hope you will be able as well to prepare this kind of soil profiles. If you need any help, please let me know. I can advise, help, etc. And we already uploaded these soil profiles. How? When we have the ml.sol or any other soil profile, you need to put it soil folder here. Then you need to go to configuration here. Reload soil profile option to be selected. It shows all the files from this soil folder, all the files. You need to select whichever you want to upload. In our case, we selected ML. See, there is an option here: select all, or select just one or several of them. If some data are in database, then you know that you can select overwrite existing soil profiles or not. And then you are uploading, clicking these soil profiles in MySQL database of Craft. This is one step. Another step is to assign particular soil profile to your location.
Me too.
Please mute, Agayaba, please mute your microphone. Agayaba,
Okay.
please mute your microphone.
Just did this. How to assign particular soil profiles? This is another topic. Unfortunately, I cannot cover everything, but again, when you come to the practical task, please feel free to apply, and I try to help as much as I can. For our case, in temporary folder, I already have, and I put soil mask. Let me find that one quickly. The exercises. This one. This one. I will upload this in, or I might have already uploaded on Google Drive. Please check Google Drive. Soil folder, it should be, yep, soil folder is here, and download this file. You see? Text file, soil, SMDT, history, etc. version 2. Please download this very small file. Download this one. Put it in your temporary folder. Put it in your temporary folder. Here. Let's check what it has inside. You see, you have the cell ID, and those cell ID comes from the craft schema file, what we have for CMDT, entire CMDT region. Totally 1,380 cells. For each cell, we managed to assign particular soil profile and IDs you see here. This ID references to those soil profiles in ml.sol file. And there is a share percent. It means that this cell contains just one soil profile. If I want to have another soil profile as well to the soil, to this grid, I can do this way. Same cell ID. I will tell just example, I will do this way. Another, but I need one split between them. Depends on your situation. So it means that per cell ID for this, same cell ID, I have two different soil profiles. One soil profile occupies 30% of this grid, another one 70% of this grid. So in this way, we can catch up the soil variability in 10 by 10 kilometer grid cell. Or better. Okay, let's skip to the case what I already have. Just one per cell. White variability already. And I'm uploading soil profile same way. Again, data, import, user. What data type we need to select? Soil. We've done with weather, soil. What is the special resolution? 5. Country. To our exercise, we are using CMDT. Okay. Vintage. Generally, soil profile data can be associated with certain years. They are not taken quite often, but we need to indicate for vintage something. I will select 2024. This value actually not used, just use the current year. Assume that our soil profile data was collected 2024. or indicated year that is known soil data were collected. Again, not it used, but let's indicate this way. Again, we need to indicate data tag later to identify. I will select as I have the file name for this. You see? The crop mask was named soil CMDT SRIC version 2, etc. And you can put same in description or indicate this was based on SRIC and HC27 dataset. Then I need to select where file is located. Again, I'll go to my temporary folder. I will select this file. Then that's all information I need for uploading. Again, let's check. Type, indicate year, data profile, where collected data profile data, resolution, country or level we are working with. Data tag is up to you, what you assign. Generally, I'm assigning the same crop mask file name. You can put description as you would like. Again, select the folder and upload. Done. That's very quick. Okay. Okay, now we are ready to move, and I'd like now to make first simulation of the data what we have and create project, etc., and later explain the. Okay, let's go to project. We will make right now first simulation project. Create. As I'm working with the CMDT region, but CMDT region is quite big, I will select third level from that region. That code is called Kotiala. This is same name, second level as well, so this should be Kotiala. This will be risk characterization type project or maze. Okay. This will be project version 1. For example, if I'm planning to do some, I will copy this one as description. So project name, Kotiala, state, subdistrict Kotiala, risk characterization for maze MZ version 1, same description. And here is the project type we have in craft. Calibration, climate change, risk, yield forecast. I will selecting the. Please mute yourself.
Excuse me.
Yeah.
Please, I thought we were working on CMDT.
Could you repeat your question?
Yeah, please, I said I thought we were working on CMDT.
Yes.
Or this is a different project we are creating.
No, we will come to that later. Give me, let me follow. So we are selecting risk characterization. 5 minutes. Country. So as you can see, there are different countries here. I will use CMDT as country. State as Kotiala. And I will come to my third district level to count. It contains 277 Kotiala as a state. CMDT even more. Go to smaller region, which is also called Kotiala. So it's 75. So that's my project related information. So general information about project, name, description, type. Then domain, we are working 5-minute resolution and specifying level. We are currently third level, consists from 75 cells. And here you can see top left and right, bottom right coordinates. This is the rectangle that covers that region. Top left, latitude, longitude, right bottom, latitude, longitude, rectangle that will cover that region. That's the project. Save. Project created successfully. The next step, we are identifying so-called run, because project can have different runs. For run, you can select different crops, but will stay generally for maize, different crop engines. We will use the DSSAT. We will use custom data set. We don't have default created for that. We will use. Please mute yourself. And I will add here run one, because with one project might be associated different run depending on inputs, selection here, etc. Save. Okay. We will come to the window where I can select the data inputs, identify data inputs. Okay. We have created for soil. We don't have system default, but we have for soil. Remember, we uploaded soil mask that is also associated with the ml.sol file. That's the soil mask. I uploaded for this exercise index that contains weather data per each grid cell, more than 1,000 per grid cell. This one. And now I will stop with tools data set and I will select crop variety, planting, and field history from the interface. For now. Shortly, we will see how we will do this. We've done this too. Soil, weather. I'm indicating that data will be provided through the interface of variety, planting, and field history. Those stars means those are the required data in order to make simulation. Save. Save. And I will move to the next step. Okay. Now here everything is empty. I don't have. So I will start creating those options. From management, I will select define inputs and will identify first field. This is the usual way we are doing this. We have add, edit, delete option, empty list. We are adding new. And we need to fill those fields. First, field history. There is a drop-down list, and based on your information, what you have, you can select one of them. I will select the first one, cultivated, under good management, initial default soil organic matter. I will indicate that history of this field, of this area, for this kind of management was 20 years. That's all. This is kind of very generic information crop model uses internally in order to define initial soil organic matter. So I'm selecting this way. And description. So it was good management, 20 years. Minimum required information regarding the fields. Save. Okay. Next one, define inputs. I'll come to crop variety. And again, similar window with adding, editing, and delete options. Empty. We have not done here nothing so far. I'm adding new one, crop. What crop we selected? Maize. For our exercise, there are some other crops in the list, you might notice, if we are working some particular crop and it is not in this list, please let me know and I will take care that it was here. Currently, we are supporting those crops. Most widely used, I think, in Africa as well, maize. With maize, there are different associated varieties we have. As you can see, there are quite long list here. Again, if your variety is not here, then we will take care and explain how you need to do this, but most commonly used one are still here. This is the Obatampa. I will select Obatampa. See here. This is the internal code GH00810. So Obatampa. And description is up to you. I can indicate code as well, GH0010, and I will shortly show where it is, comes from, and save. So base, variety, and description. Done. And the last thing we need to do, define the planting. Because main activity is starting with crop planting, so I will select here maize. Planting date. Let's assume we planted it June 29. Planting method. There are different planting methods here. Most widely used, this is the dry seed method. Plant distribution, assume it was rows. Plant population 3 per square meter. You can skip emergence. Row direction, for example, 45, direction from north. Row spacing 75 centimeters. Planting depth 5 centimeters. And description up to you. So maize, June 29. Plant population 3, etc. As you would like. So this is the general information we need to know about planting. Date, method, distribution, how many per square meters, row direction. This kind of optional, you can indicate any number. Row spacing, important. Depth, important, and description. Save. Okay. When we are entering this information, you might notice that I'm not have any choice to select it for which grid cell. This means that what you enter, define inputs, and from here, this will be applied to all grid cells. All grid cells. In order to make it more detailed one, addressing challenges grid cell level, we need to create masks that I will show later again. Again, when we are creating masks, there are different options. One is to use ArcMap under the GIS systems that allows to do this kind of things. Okay, now let's come back to our project. Remember, we stopped at data sort selections and selected inputs. I will come here. So fill the story. It shows up here. Good management, 20 years. Let's select this one. Crop variety, I indicated maize or Obatampa. It's already here. Apply. Select level and apply. And planting, this is what I created for maize, June 29. Details are here again from interface. I'm selecting this one. Apply. And all input data are already created. Any questions up to here? Any questions up to here? Okay, let me share them again and let's continue. Let's see what we have in this window. We have the project-related information, basic information, project ID, type, domain-related information, see, tab level, 5 minutes, 75. Run-related information, base, DSSAT, particular model, and run ID. First is the project information comes here, and then run ID. Next window, this is related with clock model. When we start simulation and when we finish. As we have weather data from 81, we can start 81. And as we have information up to 2015, I can do this, but in order to work quickly and to see the results, I will select 2000, year 2000, starting year, ending year 2001. Date of simulation, it will start from June 26th. Let's start a little earlier for some initial condition adjustment, usually 2 weeks earlier. Let's start June 15. Then we have output variables. By default, maturity is here. You can select any output variable related with different water-related parameters. Evapotranspiration from soil, ET, total evapotranspiration, harvest index, leaf area index, etc. I will select this one as its default, and it can be added as this way. If you want to look precipitation as well, it can take this value. Okay. As many variables you will add here, it will take more time. I will stay on this one. And then you have various statistics, starting from mean, median, standard deviation, max, mean, various percentiles. I have mean here. Let me select the standard deviation. Okay, 2 of them. Save. So one output with 2 statistics, I saved. And finally, I will run using this button, run. When you are running, yes, it will show some information over here. How many cells processed successfully, how many years simulation, and etc. If any error will show in this window. So far, we are successful. See, 15 cells processed successfully, 16, 18, 18, etc. Number of cells left.
Please, I have a question.
Yes.
Where we chose the planting date.
Oh, you mean
the planting date.
The
So
planting-
in the case where, yes, in the case where you don't want to impose a planting date, but you want to give a set of criteria, like
Yeah.
say if there is this amount of evapotranspiration with this amount of rainfall, then you should plant. How do you do that?
Okay. Now what I did currently, this is simplest way. Again, in your planting mask that I will show shortly, you can vary this planting date, but we have option so-called automatic planting, where you can indicate certain criteria, which is related to water content or window, planting window, and it will be selected from there.
Okay, so
when there is a raining season set up before that one, etc., there are certain criteria. Okay, when you come to work on this kind of thing, again, contact me and I will give some more advice on that. But yes, there
Okay.
is an option.
There's an
And
option.
yeah, there
Okay.
are options, criteria selection, wearing, etc. That's quite many options. We have
Okay,
automatic counting
okay.
option for that. Okay,
Okay.
Hello.
let me
Thank
save
you.
results here.
Hello. Hello.
Please wait for your question. Save results. This is saves results. Okay. And then you can see view results. That's the map that will show up. You see the shapes here. You see the grid cells here. You can see the values for each grid cell, as well as mean standard deviation. You can show the aggregated value when it's calculate the summary values. You see, 1925, 1936, different years. On the right side, there is a legend. See, map legend over here. What you can do more, you can increase the number of classes. Currently it's 5. You can show more classes. Or you can select different statistics. In this case, we have 2, right? Select standard deviation. You can see this one on map. If you have another output variable, you have just one, but you can select this one from this list. And again, see the results in the map. Let's go to the mean. Yeah. So this is the first simulation, first results. And I think you also could get, if you've done everything correctly, you can hide this information. There is an option exporting grid cell or entire grid, or export aggregation in the CSV format in Excel files. Okay, this is the first project we are able to run related to the risk characterization. Okay, let me stop sharing for here, and any questions here?
Hello.
Yes, Jeffrey.
Please, I have a problem here. I'm not able to get to the simulation phase.
Can you share your screen quickly?
Come again.
Can you share your screen quickly? Share your screen. Then show me quickly what is the problem. Go to
Hello.
management.
Can
Yeah, I see.
management?
Go to management. Management. Define inputs. Field. Okay. You have no enters here, right?
Yeah.
Click add. Add. Add.
Add.
Select field history. Any. Okay. Any. Any of them. 10. Indicate field history. 10 years.
You're right. I don't know, mate.
Description. Description.
Station.
Description field. There is a fields with red stars that's necessary to be filled. Put any text there, any text. Okay, save. Okay, again, go to, okay, management, input, crop variety, add, base, identify Oba Tampa, press O and it will go to them. Scroll down a little. Not that one. Oba Tampa. Description, anything quickly. Save. Management planting. Base. November 29. Sorry, June 6, sorry, June 29. Counting method, dry seed. Dry. Okay, good. Plant population distribution rows. Plant populations 3 per square meter 3. Okay. Row direction 45. Row spacing 75. This is maize crop, so the rows are quite high. Depth 5 centimeter. Description any. Okay, save. Good. Now go to the project. Project. Select inputs. Okay. Select field. First level.
Please come again.
In field history, select level 1. That one. Yep, yep. Click. Apply. Okay, second one. We don't have initial conditions. Okay, we will check on this later. Crop variety. Select crop variety. Tab. After the field history, there is a several tabs.
Okay.
Again, level, select level 1. Apply. Okay. Select planting. Apply. Okay, we need to fill the initial condition, but let's go to project or go to simulation. Go to simulation. No, simulation. Oh, sorry. Project was good. Project. Data source, select data source. You might need to make change there, data source. Uncheck initial conditions. We have not done that. Uncheck. I have not selected it. Click next. Save. Yep, save, good. Next. Okay. You're there. Now go to the simulation. Top model. Start year 2000, end year 2001. Save. I'm not changing anything. That's fine. Save, just save and click run.
Run.
Yes.
Please, I have
Okay.
a question.
Yeah, there is a problem with your input somewhere. You see, we are getting errors. You can click abort, A-B-O-R-T. Click OK. And show me your inputs once again. Go to project. No, previous one, data source. Project, data source. Yep. For weather, I did not select CMDT weather. Remember, I select in because CMDT just contains very small number. That one is correct. Okay. That contains all Otherwise, you are missing all your weather data. Click Save. Now go to your,
I should go to the simulation.
yes. What model? Everything is good here. Just click Run. You see difference? Can you see difference?
Yes, yes. The error column, you don't have numbers appearing anymore.
So cell processed 19, successfully processed 19, 21, 21, etc. Stop sharing and wait your results. Any other questions? Okay, now then move forward. Let me share screen. Can you see my screen with Craft?
Yes, it's there.
Okay, thank you.
Yes,
Okay,
please.
okay. Now we will make one step forward, make it more generic. I have one data set as well, which is related with planting. Let me open the Excel file just to show it, it's more clear. You see Excel sheet?
Yes, it's open now.
Okay, so this is the Excel sheet, and I just used to show differences, how it's different from the one what we did. So the one from the interface, apply all planting settings to all the cells. In this one that is prepared using the ArcMap and assigning different grid cells, different values, you see the cell ID that covers our region. Then in this case, actually, it was selecting the same planting date. Or it varies, you see, 1619. There was some criteria, I don't remember exactly, but yeah, there are certain criteria used to vary this planting date because different versions was prepared for this, for planting date. Plant population varies, you can see 3, 4, somewhere, 5.5. Then plant distribution rows is dry seed is everywhere, as R is everywhere, as rows distribution. This is the row spacing, this is the row direction, this is the planting depth 5. Planting depth is same everywhere, percentage per share same. So some parameters are changing, as you can see. Now, from where comes from this R code, S code, and some other codes you might need to use? In DSSAT, for 7, there is a file which is called detail.cd, this file. When to go down, here is the various code, fertilizer related, methods used, planting material. See, for plant distribution, there is a section, plant distribution. This is the code that can be used when we are working this kind of more complicated input files. R as rows, H as hills, U as uniform, and plant material and method related codes as well. See? For dry seed, we have S. R for rows. Those are codes used in Excel file R, close, S, tries it, the rest are just values. Now this is the file actually that was prepared, tab delimited file. See, tab delimited between columns. I've used Excel just to show more clearly relations between column and the value. So we will upload this planting mask to graph, this one. How? Again, data, import, user, 5-minute special resolution, data type, we have the planting mask, here is it, this. Country, we have CMDT, crop is maize. Again, we need tag. I will select the file name as tag. Description is same. I will indicate where I have this planting, it's here. This is one version. You might have different versions and with the project try different things to do. Okay. So planting 5 minutes for our region, it covers entirely this region, including Kuta. Tag, planting, maize. I select this one, description, and upload. Okay, done. Then I will create for the same project, new run, changing planting related information. So project, select. This is the same project, you see. It was already executed and there are results already associated with it. That's the result. But for this project, same project, I will create new run. For this run, crop will be the same, engine will be the same. On description, this will be run 2, where I will change planting date. Okay. Yep. So soil, same, 2 changes, weather, same. Yep. I will try to use the crop mask as well. Let me take the simple crop mask. I can go to the more complicated crop mask as well. Shortly, I should show that one as well. With crop mask, replace. This is simply different representation, but this does the same as from interface. Why? Because for each cell ID, I indicated just one variety, GH010, which is Obatampa. So in this case, I just want to show technique. Otherwise, the meaning would be same as we have from interface. I'm not changing variety over the cells. Okay, but different technique, data import as a user. Again, crop mask, 5 minutes, CMDT, data tag, I will select, again, file name, that's the mask I have. Check, it's complaining. And this crop variety mask. crop variety, and we need crop mask as well. Crop variety mask in this case. We need two things to upload. Remember how I explained in presentation? Description will be same. Okay, done. And I will upload crop mask as well. Think user templates. Okay, since I don't have it here, but no matter, it will still take by default 1 per grid cell. Let's come here, project select. This is what we are trying to use. Next, soil, weather, index. Don't make mistake here, not this one, because it contains just part of the weather files. Crop mask, I have not uploaded, I'm skipping this one, but I have crop variety mask. I have uploaded new planting approach through more variability over the grid cells. Field history we have from the interface. Everything that with red stars are filled. I will select only the field history from this interface. Again, here 2000, 2001. I will start simulation a little early. See, it changed planting date-based simulations as simulation start date, June 19. I will select a little earlier again. We'll select median, mean and median. Let me add the precipitation as an information, additional precipitation. Save. Okay. All inputs are ready. This is the new run, you see. Run 2 here. And description. Counting data, run 2. Save it again and run. Same project, different run. We changed approach to planting, which was fixed. Currently, it is not fixed. There are some variability, and there are some changes in plant population per square meter as well. The rest almost was the same. Now, all the data I'm providing, this is just versions, some version. You can consider that hypothetical, close to real data. But still, when you are working and creating your own data sets, you need to check carefully everything and document everything, what approach you are using for different data sets. I select small region because of the time we need to wait. 75, you can see quite fast. Completed. Save. Save. New results. And here is our new result for the new run based on the planting items. Quite variability, you can see between different grid cells based on the soil, weather, etc. Again, you can show the aggregation. Aggregation means here is the average values for entire area for 2 years. And then you can export. One additional feature you can use, there is a compare results. Yeah, before going that, we have 2 output variables, right? That was the maturity, yield at maturity, 1, and there is a precipitation, right? Let's see precipitation value on that. That's the precipitation over the growing season for this year. You can check per cell what's going on. There is a legend, small precipitation to higher, somewhere 500, check the variability, etc. Okay, let's select this one. We looked on mean. We can check median. It seems I mistakenly select the median. You can see the median as well on map. And finally, we can compare results of 2 runs. Run 1 as run 1 here, that's current run. This, we changed planting date, and the previous, what we did as a run 2 for comparing purposes. This was the project. This was the run ID, first one. And I can compare differences between them or percent deviation. Okay. These are comparisons between 2. Or deviation. You can compare, you can make conclusions on this. You can do this, can do the same. We had 2 statistics only for second run because of this, only 1 mean is available here. You can increase classes, number of classes, or decrease and compare based on this in more detail. This is the result run for the first one, which was the updated one. This is the second. So when comparing, it uses the current one as first run and the second previous one as a run 2 for comparing purposes only. And the results comparison. It's quite powerful tool in order to make comparisons between different projects on aggregated level as well as per grid cell. Okay, so what we have left regarding the management, this is we can add initial conditions, that's simple, no problem. We can add more management related information like fertilizer, inorganic or organic, irrigation from interface, as well as grid cell level. Okay, let me stop here. This was the risk assessment type project where you can estimate and compare different strategies you have. Might be related management, it might be related location, where you're growing crops, what crops are you selecting, and etc. Okay, let me stop here today. And I am open for your comments, suggestions, questions, discussions, or whatever you have next, maybe 15, 20 minutes.
Let me